Hey guys, this is acservicetech, and today what we're going over is CO2 refrigerant, and that's R-744 refrigerant. We're going over some of the history of it, some of the properties of it, and why it's presently being used and why we may be using it more in the future. This video is brought to you by Danfoss and our patrons over at patreon.com/acservicetech. We're using the resources found at Danfoss Learning here, and you can access Danfoss Learning through the Refrigerant Transition Center. There you have access to a bunch of resources and also apps that Danfoss has developed for technicians to be able to use. And they also have Refrigerant Week coming up, and you can sign up for free webinars and learn more about lower GWP refrigerants and also natural refrigerants. So I have that link down in the description below. So you see on the timetable of CO2 refrigerant, it started in the 1850s, and then it progressed from there and got used more and more, and then all of a sudden in 1930, it stopped being used as much, and that's because of the introduction of the CFC refrigerants and the HCFC refrigerants. And so from there on, CO2 was put on the back burner. You see now 1993 is when things started to change, and that's because we had the Montreal Protocol, which was basically designed to reduce the amount of ozone depleting refrigerants being used. The issue with that is then we had refrigerants that were being designed and used that had a high global warming potential. And then we had the Kyoto Protocol, and that was used to reduce the amount of refrigerants that were being used that had a high global warming potential. So that limits the amount of refrigerants that could be used, and as you get closer down to 0 ODP and 0 GWP, you're left with CO2, and then also flammable refrigerants such as propane, which is R290. So as we move on with refrigerants, and the manufacturers are looking at the different refrigerants, there's a thought process out there. Do we just want to reduce the global warming potential, or do we want to just go with a refrigerant that we don't have to phase out again? So here's some facts about the CO2 is global warming potential is 1. And that's because global warming potential is compared against CO2 in all applications. So if you try to find the global warming potential for R22, you're going to compare that against carbon dioxide, which is what we're talking about now. So that's why we have 1 for global warming potential. ODP, ozone depletion potential, is 0. You see a low critical temperature of 88 degrees Fahrenheit. So that's a bit of an issue, so that we can't use it in areas where we're going to have a condensing temperature higher than that 88 degrees Fahrenheit. And you also see the high pressure there at 88 degrees Fahrenheit. You're looking at 1080 psi. So that means that the compressors and the lines and everything have to have a higher pressure rating than systems that you might be used to. The triple point, I'll explain that in a second when we go over to that slide. It's non-flammable and it's non-toxic. In reference to the pressures, for every 1 degree Fahrenheit, you have to increase the pressure 8 psi. So that's a high pressure increase. In reference to the line set sizing, as you can see down here in the bottom right, CO2 is for the vapor line is a lot smaller than you'd need for other refrigerants. The heat exchangers become more efficient due to the volume of the CO2 being much higher than another refrigerant that we're used to using. Here you see once again the pressure increase, so you see pressure versus temperature, and you can compare that against a lot of other known refrigerants, and you see that pressure increase in order to get to a higher temperature. So here between the critical point and the triple point is where basically you have to keep the operating parameters at in order for efficiency and also for the safety in the system. You know, you don't want to be working with a solid CO2. You need to be in the area where you can have either liquid or vapor at the same time in the system. So you're not going to have the condenser in a high ambient situation. Here's a comparison of CO2 R22 and R134A, and you can see that the CO2 has a very high capacity, and that's just due to the volume of refrigerant that can travel through that tube. Same thing with the compressors. They can be smaller because you have a larger volume of refrigerant in a smaller area. Because you have such a high pressure, you also have a very low pressure drop. And so you know, if you're looking for more information on CO2 or other natural refrigerants, or you're just trying to learn more about the HVACR field, you can check out the Refrigerant Transition Center, and make sure you pan down to the bottom of the page so you can check out some of the other popular resources at the bottom. You can go to the Danfoss Learning Center and you can go on to those e-lessons. They're very, very good and well put together. So I would definitely sign up for that and take advantage of those free opportunities. I have a direct link to get there down in the description below. Sign up for the webinars for the Refrigerant Week, September 24th to 28th. If you want to help support this HVACR training channel, click right here. If you want to subscribe, click right here. And if you want to see another HVACR training video, click right here. Hope you enjoyed yourself, and we'll see you next time at AC Service Tech channel.